Hello, so in this video we're going to talk through the second week's activities, which is all to do with surds and indices. So our first question we have is 216 over 1000 all raised to the power of negative 2/3. Now if you remember, there is a law of indices which allows us to deal with a negative power. And the law is that you just flip the fraction upside down. Okay, so let's do that first. So 216 over 1000, because it's being raised to a negative power, I can treat this as 1000 over 216 raised to the power of, now I just need to make sure I raise it to the positive 2/3 instead of the negative. Okay, the negative just means cross the line, which literally means that the numerator and denominator change places and change the sign. So cross the line, change the sign. All right, now because I have a fraction raised to a power, it just means that both the numerator and denominator get raised to that power. So I have 1000 to the 2/3 over 216 to the 2/3. Okay. Now, because I have a fractional power on both the numerator and denominator, just remember the fractional power just means that that denominator, in this case 3 in both cases, climbs down to become a root. So in this case it's going to become a cube root. So let me write that in. So I have 1000 cube rooted, because that's what that 3 does, it climbs down, and I still keep this 2 up there, it's still the power of 2, and the same on denominator as well actually. So I have 216 cube rooted to the power of 2. Now it's worth noting that it doesn't really matter in which order I do these things, so whether I cube root first and then square, or whether I square and then cube root. But because I've got fairly big numbers, like 1000 and 216, I'm kind of stretching the limits of what I know to be the cube root of numbers at this point. So I think I'm going to cube root now before I make the number bigger by squaring. Okay, well the cube root of 1000 is nice and easy, it's just 10. So I have 10 and I keep it to the power of 2. And then the cube root of 216 should be 6. And then I should have to square that, okay? So, okay, I'm just then left with 10 squared, which is 100, over 6 squared, which is 36. I could, if I want to, cancel that fraction down, so that could become 50 over 18, or even further than that, it could become 25 over 9, okay? So that would be my final answer there. All right, so for the next question, we've been given that x is a number which is greater than 1, okay? So we don't have to worry about zeros or negatives or fractions which are less than 1 in there. But given that that is the case, can you write the expressions in order of size from smallest to largest? So we have x to the power of 0, x to the power of 2, x to the power of negative 2, and x to the power of 1/2. So first things first, I'm just going to rewrite a couple of these things. Hopefully you notice that x to the power of 0, well, given the fact that x is greater than 1, we don't have to worry about 0 to the power of 0. So it's going to be a number to the power of 0, anything to the power of 0, as long as it's not 0 of course, is just 1. Okay, so x to the power of 0, I'm going to rewrite this as 1. X squared, well, I'm just going to leave that as x squared for the time being. Then I have just x, so I'm going to leave that as x. Okay, x to the power of negative 2, I'm going to write that as 1 over x squared. Okay, because that's literally what that means. And then x to the power of 1/2, I'm going to write that as, I'm going to write that as the square root of x. Just remember that that's a fraction, so I can treat it as a root instead. Okay, so this is really what I'm thinking about when I'm thinking about that list there. I've just rewritten a couple of things. Now, given the fact that I've got a number which is greater than 1, I could just choose a number greater than 1 and just try sticking it into each of these things. Okay, so if you're really not sure, just choose a number and then just stick it into each of these things. But because I'm kind of understanding of kind of what should happen with each of these operations, I guess we should be able to figure out just dealing with it generally without actually choosing a number. Okay, so first things first, we've got 1, we've got x squared, and we've got x. Now, because I know that x is going to be greater than 1, I know immediately that x has got to be bigger than that. Okay, so I know for a start, because I'm going from smallest to largest, that x has got to be to the right of 1. Okay, so maybe if I just start by just putting a dummy list in, so I put 1 here, and I put x over here, I know that x has got to be greater than 1. But more than that, if I take a positive, or if I take a number greater than 1 and square it, it shouldn't generally get bigger. So if I take 2, for example, and square it becomes 4, or 5 and it becomes 25, or 7 it becomes 49, right? So in general, if I take a number bigger than 1 and square it, it should be bigger than x. So therefore, I think on the end here, x squared should be bigger than x. Of course, it is important that there is that distinction that x is greater than 1, because of course if you try sticking a fraction in here, like a half, if I square that, that's going to become a quarter, which is smaller. But we don't have to worry about that. We've got x greater than 1, so I think we can be confident that x squared is going to be bigger than the number that we square originally. Okay, so next, let's have a look at the 1 over x squared. Well, clearly, because x squared is going to be a number which is like 45 or 29 or 25 or 36 or 81 or whatever it might be, if I do 1 over that, so 1 divided by that number, it should become smaller, okay? And in fact, it should become smaller than 1, okay? Because it's going to be a number bigger than 1. X squared is going to be a number bigger than 1. We've just said that. So if I do 1 divided by that number, it should become smaller, okay? And we don't have to worry about negatives at all in here either. So okay, we can put 1 over x squared to the left of this. Next, it's just a case of considering, well, what about the square root of a number? Where in this list does this fit? Well, okay, if I take like 4 and I square root it, it should become 2. So it should be smaller than the number that we started with. So I know that if we start with x and I square root it, we're looking at a number which has got to be on the left-hand side of that. It's got to be smaller than that. But the question is where? Well, given the fact that x is greater than 1 to start off with, and the square root of 1 is just 1, it means that any number which is bigger than 1 square rooted must also be bigger than 1 as well, okay? So therefore, I know confidently that square root of x should fit here in my list, okay? So that now is the order of my list, okay? So this is the correct order. But of course, I'm not going to leave my answer like this, because I need to make sure that I give it in terms of the original expressions I was given. So okay, I had 1 over x squared first. Well, 1 over x squared was my x to the power of negative 2. Then I had 1, well that was just x to the power of 0. Then I had square root of x, well that was just x to the power of 1/2. Then I had just x, that was fine because that was in the list. And then I had x squared, so that was also fine, that was in the list. Now, you also notice that have a look at the order of the powers. Because I got given a number which was bigger than 1 to start off with, so x was bigger than 1 to start off with, I could have just looked at the powers and realised that if I put those in order of size, given the fact that's 1, then I would have also got the answers in the right order as well, okay? But of course we have to just consider a little bit more carefully, because we might have situations which were less than or equal to 1. But if you just put them in order according to the powers, that is also fine in this case. All right, so the next question then, we had a big sort of complicated equation involving h, but let's just break it down in parts. I'm going to look at the first part, I'm going to look at the left side of the equation first of all. So I've got the cube root of h squared all raised to the power of 2/3 on the left hand side of my equation. I'm just going to work with that for the time being. Alright, so first things first, I'm seeing a power up here, but I'm seeing roots inside the brackets. Okay, so first of all, I'm going to make sure that I have a power which is the same both inside the brackets and outside the brackets. So in other words, no roots. I don't want to see any roots here. So the cube root of h squared, hopefully you realise that I can just write that as h to the power of 2/3. Okay, so that's the bit inside the brackets. Okay, this part here, I'm just treating that as h to the power of 2/3. Literally what I'm doing is a reverse of my sort of conventional law. I'm realising that if I have a denominator, it climbs down to become a root, and vice versa. So if I have the root, it must climb up to become the denominator. All right. So that's my first part, but I'm still raising all of this to the power of 2/3. So now I can just employ a law of indices which says, well, if I have h to the power of something, and then I raise all of that to the power of something, I just end up multiplying the powers together. So I have h to the power of 2/3 times 2/3, and then this is just a game of multiplying fractions together. So 2/3 times 2/3, that's going to become 4 over 9. All right, so 4 over 9 there. But remember, that is only working with this part of the formula. So I'm just going to pop that back into my formula down here. So instead of writing an entire left-hand side with all the roots and the powers of 2/3 gubbins, I'm going to write it as h to the power of 4/9. And then this is going to be equal to the right-hand side, which is h to the power of x over h to the power of 5. All right, good. So in order to solve this equation, I need h to the power of x. So what I could do is multiply through by the denominator just to get h to the power of x on its own. So I'm going to do that now. So I'm going to have h to the power 4 ninths. Then I'm going to multiply by the denominator of the right-hand side, which will just leave me with h to the power of x on this side here. Okay, so if I just push myself out the way, then actually this is relatively straightforward, because if I look at the left-hand side, I have known powers over here. So I just need to take 4 ninths and add 5. Okay, so that's going to become 49 over 9, I believe. So h to the power of 49 over 9 is equal to h to the power of x. Well, in that case, then I can just directly read off that x is equal to 49 over 9. It's literally just saying, okay, h to the power of something equals h to the power of something. Those two powers must be the same. Okay. All right, so next question then. We've been given that 3 to the power of x is equal to 9 to the power of y minus 3. Find an expression for x in terms of y. So what we're ultimately doing here is, because we have two unknowns in our equation, an x and a y, but we only have one equation to use, we can't find x and we can't find y. So all it's asking for us to do instead is just to write an expression for x. So we want x equals, and then just stuff involving y on the right hand side. Okay, so let's see if we can do that. So we've got 3 to the power of x is equal to 9 to the power of y minus 3. Now the first thing that you notice is that it's not just as easy as just reading these two powers off together, because the issue is we have different bases. We have a 3 on this side and we have a 9 on this side. But that's okay, because we can make the base the same by treating 9 as 3 squared instead. So if I want the base the same, I could just treat 9 as 3 squared. Then this equation would become 3 to the power of x is equal to 3 to the power of 2, and then just to make sure I capture everything, I'm going to put it in a bracket, and then to the power of y minus 3. So I'm writing the same thing, but instead of writing 9, I'm just writing 3 squared. That's all I've done there. Okay, now I can employ my laws of indices, because look at the right-hand side. Because I have 3 to the power of something, and then I'm raising all of that to the power of something, I just have to multiply those two powers together. So I'll end up with 3 to the power of 2y minus 6. Be careful to make sure that you multiply the entirety of y minus 3 by 2. Not just the y, it's the y and the negative 3 by 2. Okay, so now I'm in a position, because I have the same base, because I have 3 to the power of something equals 3 to the power of something, then I can just directly read off that 3 to the power of x must be equal to 3 to the power of 2y minus 6, which literally just means that x is equal to 2y minus 6. Okay, the two powers must just be the same. And actually, that's all I need to leave my answer as. So actually, let me do it in black. I can literally say x is equal to 2y minus 6. That's all I need to leave my answer as. Because if you have a look, I wanted x in terms of y, which means that I wanted x equals, and then just purely y's on the right-hand side. That's what I've got there. So the answer would be x equals 2y minus 6. Okay, so with this question then, we've been given that an expression involving 2x squared minus x to the power of 3 over 2, all divided by the square root of x, should just be written in this form of 2x to some power minus x to some power, where p and q are just powers. Okay, so ultimately all we're being asked to do here, it's quite a complicated way of asking. Here we have 2x squared minus x to the power of 3 over 2 over square root of x, simplify it. That's ultimately what this question is saying. It's just saying that we want it written in this form, which to me looks like a simplified form. All right, so first of all, I'm going to have a look at the thing which I've been given, the expression I've been given, and I'm going to see what I can do with it. So first of all, you notice that I have a square root of x on the denominator. So I want to ideally just write this as x to the power of something. I don't really want roots confused in here. So I'm just going to write the numerator out again, but then the denominator, I can write that as x to the power of 1/2. Okay, just remember that that's our laws of indices there. Now I can separate this into two separate fractions. So I can have 2x squared over x to the power of 1/2 minus x to the power of 3 over 2 divided by x to the power of 1/2. Now, if I have a look at each thing separately, that's almost what I want, okay? Because I've got 2 and then x's on there, minus just pure x's, so no constants, which is very, very close to what I'm after. The only thing is that I've got kind of fractions still going on, whereas the thing which I want doesn't have any fractions, just has x to the power of something. But that's okay, because you see here that on the left-hand side, I'm just dividing. Okay, so if I take x to the power of 2 and divide it by x to the power of 1/2, that should just mean that I subtract those two powers from each other. So I'm going to leave the 2 in there because the 2 doesn't really get mixed with those two x's. So I've got x to the power of 2 divided by x to the power of a half. If I subtract the powers, I get x to the power of 1.5 or x to the power of 3 over 2. Okay. And then on the right hand side, I just have to do the same. So again, x to the power of 3 over 2 divided by x to the power of a half. If I subtract those two powers, I get x to the power of, well, 3 over 2 subtract 1 over 2 is 2 over 2, or just to the power of 1. So therefore, I can say that this is 2x to the power of something, look, 2x to the power of something, and this is x to the power of something, look, x to the power of something. So I can just read off what p and q is directly. It means that p must be equal to 3 over 2, and q must be equal to 1. Okay, so that there would be my final answer. Okay, so for this question, we've been given a diagram which shows 2 red squares and 1 yellow rectangle. And we've been asked to find the values of x, a, and b. Okay, so first of all, realise that the numbers written inside the shape, so the x, the root 80, and the 16, they are just the areas of each of those shapes. Okay, and then a and b are just the side lengths of the 2 squares. All right, so first of all, I think we can read off directly what b must be equal to. Because if you remember, if I have a square with an area of 16, in order to find the side length of that square, which in this case is b, I can just do that by taking the square root of the area. So the square root of the area must be the square root of 16, which is just equal to 4. So actually I can write here that b must be equal to 4. Now you notice that because of the way that the shape is constructed, because this side length is 4, it means that this side length must also be 4 as well. So next thing to do is to think, well, okay, if I have the area of a shape and I know one of the side lengths, if I want to find out the other side length, which remember is just a because of this side length down here, then I just have to multiply those 2 side lengths together and it should give me root of 80. Okay, so in other words, I'm saying that 4 times a should give me the root of 80. So how could I find a? Well, quite simply, I could just divide these 2 things by each other. So root of 80 divided by 4. Now, I don't really want to leave my answer like this if possible. I want to try and simplify. So have a look at root of 80. I think using surds, we should be able to simplify this. So root of 80 should be the same as, let's see, should be the same as root of 16 times root of 5, shouldn't it? Because 16 times 5 should give me 80. Of course, if you didn't spot that straight away, it doesn't matter. You can still break it down as many times as you like. So, okay, this should just be written as 4 root 5. So I'm just going to replace this over here. The numerator becomes 4 root 5, and we still have the denominator of 4. Well, that's handy, because this means that 4 divided by 4, that cancels. Therefore, I can literally say that a must be equal to root of 5. So let me write that in there. So a is equal to root of 5. Now, the last side that I need to, or the last value I need to find is x, which is the area of this square. So again, if I get given a square, let me just write it up here. And if I don't know the area, but I do know the side length, which in this case is root of 5, then I just do the reverse of what I was doing over here. So instead of square rooting, I must just square the side length. Okay? So x must be equal to the root of 5 all squared, which is just equal to 5. So let me just summarise down here then. We have a, which was equal to 4. We found, a was equal to root 5. B, which was equal to 4. And x was equal to 5. Okay, so those were the 3 values there. All right, so next question then, very, very similar to the last question. It's just that in this case, we've been given a square, and it's a full square, which has been divided into 2 red squares and 2 yellow rectangles, okay? But the side length of the whole square is 4. All right, so let's figure out what this is going to give us then. So, first of all, let's look down here. Let's figure out what the side length of this square is. Because we know that the side length of the full square is 4, so if we can figure out what the side length of that little red square down there is, we should be able to figure out what this part here is, okay? So, just remember, if I've given you the area of a square, to find the side length, I just take the square root. So the side length of this square should just be root 11, okay? It really is as simple as that, okay? Which then means that the side length down here, let me just sort of write it in a different colour just to make it clear, because I'm not going to be able to fit this in. The whole side length is 4, so from here to here is 4. and I'm taking away this root of 11 to leave me with the side length that I want. Okay, so in other words, this is going to be 4 subtract root 11. That's what that side length is going to be. Okay, now have a look, because I should now be able to find the value of x. I know that the side length over here is also the same as root 11, because it's clearly just a square, okay, which means that this must also be root of 11 as well. Okay, so therefore, in order to find the value of x, I'm just going to have to take my two side lengths, which are root 11 and 4, so I'll put it in a bracket, 4 minus root 11, and multiply the two things together. So okay, just use my distributive law. I get root 11 times 4, which is 4 root 11, minus root 11 times negative root 11, that's going to give me negative root 11 squared, which is 11. Okay, so in other words, I know that x is going to be 4 root 11 minus 11. Okay, so therefore, in order to find the value of y, I'm going to have to think about what this side length is. Given the fact the red square at the top there is a square, if I find the side length, I can really easily find the area just by squaring it. Well, actually, that's not too hard to do, because if you realise that x, I've already found, is 4 minus root 11, it also means that this must also be 4 minus root 11 as well. You can also think about that as the whole side length of the big square is also 4 as well, because of course it is a square. Okay, but either way, I know now the side length of the square is 4 minus root 11, which means that y should just be take that side length and square it. Well, squaring this, you can just think about this as 4 minus root 11 times by 4 minus root 11, okay? Which means that if I use my distributive law, I get 4 times 4, which is 16, 4 times negative root 11, which is negative 4 root 11, negative root 11 times 4, which is negative 4 root 11, and then negative times a negative, which is a positive, root 11 squared, which is just 11. So tidying this up then, I get 16 plus 11, which is 27, minus 8 root 11. Okay, minus 4 root 11 minus 4 root 11 is minus 8 root 11. Okay, so I think we found everything we need. Let's just double check. So I got x was equal to 4 root 11 minus 11. Let me just make sure that is definitely 11. And then I got y was equal to 27 minus 8 root 11. Okay, good. Okay, so the next question then, we've been asked to simplify this surd. We've been asked to simplify root of 450. Okay, well, root of 450, I just need to find two factors that multiply together to give me 450, and I want one of those things to be a square number. Well, hopefully you're able to see that although 450 isn't necessarily one that I work with a lot, I do work with 45, and I can really easily find those factors. So for example, 45 is 9 times 5, which means that root of 450 must be equal to root of 9, and not times by root of 5, but root of 50. 9 times 50 is 450, okay? That's going to give me 3 root 50. Now, the temptation is to think, great, I've simplified, I've done something, I've finished. You haven't, because you need to have a look to see whether that surd can simplify any more. So let's have a look at this. Can root of 50 simplify? Well, actually, yes, it can, because 25 times 2 is 50. So therefore, I can write this as root of 25 times root of 2. That's going to give me 5 root 2. So therefore, I have 3 times 5 root 2 instead. 3 times 5 is 15. So I think the final answer should be 15 root 2 instead. Okay, so this question then, we've been asked to expand and simplify these two brackets. I think we're going to be using our 2 happy faces, 2 sad faces, or whatever you want to call it. Okay, so we'll take these two things. Let me just write it out again. Okay, so first of all, I'm going to take root 3 and distribute it over my bracket. Okay, so I'm going to have root 3 times root 27, and root 3 times positive 2, which is going to give me positive 2 root 3. And then I'm going to take my negative root 12 and distribute it over my second bracket as well. So negative root 12 times root of 27 times by negative then, because I'm going to take negative root 12 and times by 2, so I can write that as 2 root 12. Now you notice, I've been very, very careful to make sure that when I've got my surds, I leave it as the surds. Okay. The reason being is because 12 times 27 is going to be much more difficult to simplify than just simplifying the root 12 and then the root 27. Okay. So let's go through sequentially then. Well, first of all, you notice that root of 27 can be treated as root of 9 times by root of 3, which is going to give me 3 root 3. Okay, I can't do anything with the next one, but I can simplify root 12. That's going to become root of 4 times root of 3, which is 2 root 3. And root of 27, well, we've already done that one, that's 3 root 3. And then again, root of 12, we've already done that one, that's 2 root 3. So in other words, I'm going to write this thing as, let's be careful here, I'm going to have 3 root 3 times by root 3 as my first term. The positive 2 root 3 term remains. Then here, I'm just going to write this as minus, well, I'm just going to multiply these two things together. So I'm going to have 2 times root 3 times root 3, and then I'm going to times it by 3, so it's going to be 6 times root 3 times root 3. So 2 times 3 times root 3 times root 3. And then minus, lastly, I've got 2 times by 2, which is 4 root 3. And then I can just go through here and I can just make sure that root 3 times root 3 is just 3, so therefore this is going to become 3 times 3, which is 9, plus 2 root 3, minus, again, root 3 times root 3, that's going to be 3, so 6 times 3 is 18, and then minus 4 root 3. Okay, so that there would be a simplified form. Actually, I can take this a little bit further, can't I? Because you notice 9 take away 18 is negative 9, and 2 root 3 minus 4 root 3 is negative 2 root 3. Okay, so I can leave my answer like this, fully simplified. Okay, so final question then asks us to rationalize the denominator and fully simplify. So we have 3 root 10 over 4 root 2. So I've got to think, what have I got to multiply by? The thing which is making this denominator irrational is that root 2. So I'm just going to multiply by root 2 over root 2. Of course, there are other things you can multiply by. For example, you could multiply by 4 root 2 over 4 root 2. But just because I know that the thing that is making the denominator irrational is the root 2 in this case, I'm just going to multiply by root 2 over root 2. Okay, so therefore I get 3 times by, well, I get root of 10 times root of 2, that's root of 20. And on denominator, I get 4 times root 2 times root 2. Just remember, root 2 times root 2 is root 2 squared, which is just 2. So 4 times 2 then should be equal to 8. So therefore, I'm just going to have a look at this surd, see if I can simplify. Oh, yes I can. Okay. So root of 20 is equal to root of 4 times root of 5. So root of 4 is 2, and I've got root 2 times 5 there. So in other words, I get 3 times 2, which is 6, root of 5 over 8 there. And have a look. Remember, just ignore that root of 5, just treat it as 6 over 8. Okay, 6 over 8 simplified would be 3 over 4, so I get 3 root 5 over 4 there. Okay, and that there would be my final answer.